Okay, so today's video is going to be about today's video is going to be about quantum mechanics, again my favorite topic. And then we will be talking about today let's have a detailed talk about quantum mechanics. What is quantum mechanics? What is quantum mechanics? What are the phenomena of quantum mechanics? What technologies are made using quantum mechanics? And what are the branches we have using? We have the word using quantum. Okay, so first of all, introduction. Introduction. Introduction to quantum mechanics. We will talk about the one who started quantum mechanics, Max Planck. Max Planck. Okay. Who was Max Planck? Yes, he is the person who said energy is discrete, not continuous. Continuous. Okay. What I mean by discrete is if these are level of energy levels and this is an electron on the okay, yeah, this is known as lowest level of energy. Okay, so when let's suppose a photon is hits this electron, what is photon? Photon is E equal hv. Here E means energy, photon is nothing but energy. So when it hits electron, what happens that electron gains energy and it will get excitation. 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 Okay, then what happens, even the same process vice versa, that when it goes down it will lose energy. That's de excitation. Lose energy. Okay, so this is what energy is all about. And one more thing, energy is directly proportional to frequency cube, shown by UFT. It is called energy density, uh, 8 pi h frequency cube over c e to the power hv kt minus 1. Okay, here this is energy density. Energy density. Okay, so if if I say energy is directly proportional to frequency, but it's also inversely proportional to lambda cube, because yeah, then what else do we talk about? This is introduction. Right now we're talking about the introduction. So the introduction to quantum mechanics is that energy, that there's smaller units of photon. Photon have have small fundamental units. Fundamental units known as uh, quanta. And it so then after 2 to 3 years it was known as quanta of light. Quanta of light means photons. Okay, then when we talk about, okay, we have already talked about how Max Planck said the energy is discrete, and it focuses on frequency. Energy cannot be continuous, and so here boson bosons are used for the experiment to find if energy is discrete or not. Because why bosons? Because bosons have integer spin, integer integer spin. Okay, and actually this equation over here, it's E equal NHV. N stands for whole natural number. Okay, then what happened after that is that using this concept, energy is discrete, we come to Einstein. Einstein, what did Einstein do? He used this equation, used concept of discrete energy to make or to discover, I think it's discover is better, discover a photoelectric effect. Okay, let me illustrate what he mean. He said that, and he said that a light is a photon, and photon is what? E equal NHV. Okay, then the energy is given to this particle photon, so not for the electron. Okay, so what happens that photon give energy to electron. Why it needed energy? To escape the binding force, because the force between the energy, binding energy, not force. This is, I think this is a symbol for this energy, if I'm right. And when when it is when it's free, the electron gains what is it, kinetic energy. Okay, kinetic energy, K dot E. Okay, uh, here one more condition, energy should be particle. Okay, why I said energy should be particle? Because not energy, photon should be particle. Why? Because light has a dual nature. Okay, why? What I mean by dual nature? It's a particle, it's a wave. If I want to show, this is a particle, this is how particle will be, and this will be wave. Okay, then if I, oh yeah, formula. Okay, the formula is uh, E equal H, not E equal HV. It should be HV equal 1 by 2 mv square plus psi. Okay. So then, uh, yeah, this is the formula. Again, this is the binding energy, kinetic energy, and the energy provided by the photon. Okay. Then again, let's get to. Okay. Now we are getting into the phenomena of quantum mechanics. Phenomena. So phenomena of quantum mechanics. Okay, let's get interesting. Of QM, quantum mechanics. Okay. Number one, superposition. Again, what is superposition? Superposition, the state of being in more than the state of being in more than one place, more than one place, more than one place at once. The state of being in more than one place at once. Okay. So if I want to give example, uh, this particle and this particle, uh, same particle but different place. Okay, how I can define it? I can define, or after, let me do one more thing, and then we'll talk about it. Then we have super tunneling, tunneling, tunneling. Wait, okay, so then we have what we have super tunneling. What is super tunneling? The concept of phasing, concept of phasing. What I mean by concept of phasing, that electron goes through this, let me make it as simple as possible. Here, probe to phase, but as a wavelength of a particle is less, as E equal h c over lambda. uh, Wait, sorry, lambda is less, so energy is more to phase. as as I think it's yeah. uh, so what happens, this is what, okay, yeah, fun fact, fun fact. What is this fun fact? Wait, let me write over here. Fun fact: the sun does superposition, super tunneling. Sorry, super tunneling. Okay. Because how, okay, let me define. When when the sun, two part, because we know that what sun does, it does fusion. Okay, sun. Okay, what sun does fusion. When it's doing fusion, and fusion between what, two helium atom, helium nuclei. What will happen when they, because of them being same, they will oppose each other. Okay, they will oppose each other, oppose. But but because of the high pressure or inward force, because of high temperature pressure or for inward force, the helium nuclei opposing force is overpowered. Okay, then yeah, because of high temperature, high pressure, and of course inward force, as the sun's gravity is denser. Okay, then what else do we have? We have quantum superposition, so super tunneling. If I go on, I can say even more. Then we have thought experiment. Let's talk about thought experiment. I have not talked about thought experiment till now. Thought experiment. Uh, there are Schrödinger's cat. Schrödinger cat. Okay. The most famous, which is Schrödinger cat. What it is being. This explains superposition. Being in a being in a state of dead and alive. What I mean by that? Wait, let me see. The wait, what was it? What was it? The experiment is that we have a box and we have a kitty cat in this. Let's suppose kitty cat. Well, it's a very bad drawing. Don't just ignore my drawing. Cat. And with this cat, there's a bomb. Yes, there's a bomb. But and this bomb chance is 50-50, means there's 50% chance it will explode, 50% chance it will not explode, depending on what it is. So till it is not observed, or the box is open. What I mean by that, the cat is in superposition state. Okay. Quantum mechanics answer. Actually, this experiment is Schrödinger's experiment, and the concept or the reason behind making this experiment was he wanted to show how obscure or how difficult or weird behavior quantum mechanics has. So it's he made it out of angry, or because he couldn't understand quantum mechanics. So in superposition state. Okay, let me write normal answer. Normal answer. Okay. By normal answer, it would be either dead or alive or alive. Yeah. If it's two, then it will become more than one. Right. Okay. Yeah. And then we talk about yeah. Let's get into theory of quantum mechanics. Theory of QM. Okay. Psi of x and t. What is psi of x and t? Wave function. Wave function. Expand. Expand. Psi of x and t equal psi of 1 plus psi of 2. What I mean by this is a probability factor that explains wave. And let's suppose if we have a field and we want to find in this field where is the electron or the particle, we use psi of x and t. Okay. This is part of Schrödinger equation. Schrödinger equation. Okay. Okay, let's study one more. Yeah. Then we have constructive and destructive wave. Constructive waves. Okay. Constructive waves. What are constructive waves? Let's suppose if I have this plus, now result is double the size. So if I, okay, let me write. Here we will talk about amplitude, amplitude, and so on. Okay. But here we have a difference. This amplitude is the combination of these two amplitude. It's amplitude plus amplitude equal to 2 times the previous amplitude of the two waves. It's a together, it's a combined wave. So if I write in symbols, I think it's this symbol plus this symbol. It's a symbol for amplitude to get two of these symbols amplitude. Okay, this is how it's same thing. Symbol form. Okay. Then we have the destructive wave, opposite of constructive wave. Destructive waves. Okay. 1, 2, 3 plus Here we have 1 2 3 4. Sorry, 1 2 3. Now what's the result? Yes, you got it. You got it correct. It is a plane line. Why? Because these two cancel each other out, and when they cancel each other they give a plane value. And this is what physicists or quantum physicists do. They try to, this is what also helps helps understand the wave helps understand the position of electron. Yeah. Then we have Heisenberg uncertainty principle. Heisenberg uncertainty principle. What is Heisenberg uncertainty principle? It's a measurement in which if one measurement is made of one quantity, it will affect the measurement or the preciseness of the measurement of the other quantity. This is the formula. Okay, this is if we measure momentum. Okay, if we measure momentum, the measurement or preciseness of measurement of position will decrease. What is the search bar? The search bar is reduce Planck constant. Reduce Planck's constant. Okay. Then let's suppose this is momentum, a particle or in a wave form. Okay. Position of particle in, what is this? A particle form. Okay. What else? We have reduced Planck constant. Yeah. So what I think is that we can integrate my thought. Okay. What is my thought? My thought is we can combine Schrödinger equation with Heisenberg uncertainty principle. Okay, to make measurement more accurate. We can never get exact value. Let me go back to the first page and let me write here. Can never get exact measurement. It's always probability. Superposition. Okay. This then there's more as well. We have a lot. if I start doing it, I can talk a lot about it. Then we have quantum entanglement. Quantum, it's a huge topic. So quantum entanglement. Two particles, no matter the distance, are entangled, entangled, entangled. It's proven and helps do quantum teleportation, which was done by the physicist in teleportation, done by physicists in 2022, and they proved Einstein wrong. Then yeah, quantum field theory. Yeah, sorry. Yeah, the particles connected, information is being transferred. Let's suppose I. For me, I always take I as information, and being transferred, transferred. Okay, and this relation is what makes it quantum mechanics so mysterious. So many mysterious phenomena, but all the all the quantum mechanics works on when the area or particle is not observed. All all probability is possible, and this is called uh, observed. Yes, thank you.